All right, so in 6-6, we're going to solve radical equations, and with these, there also might be extraneous solutions. Do you guys remember what an extraneous solution is? Anybody tell me what it is? Yeah, one that looks like it's a solution, but then you plug it back in, okay, you see that it's not a solution. Okay, so it looks like a solution, but it's not. So when we are solving these radical equations, we have to remember how inverses work. So if we undo an operation, we're using the inverse, okay, and that is the inverse operation of a root is going to be a power. Okay, and then if we are undoing a square root, we're going to raise each side to the second power. Okay, for a cube root, we would use the third power. For a fourth root, we would do the fourth power. Fifth root, we would do the fifth power. Okay, and that happens no matter what is inside the radical. So a lot of times we just have seen x inside, but we could have a binomial. So if you have x plus 1, that's going to apply as well. And then we also want to be thinking about powers as well as the roots. Okay, so we know that inverse operation would be a root or a radical. Okay, and a power is an exponent, so powers exponents, the inverse would be a root or a radical. So if we had a quantity raised to the power of 2, we would use the square root. And if it's a power of 3, we would use the cube root. Okay, and I don't care if you write cube root or if you put the cube root of 3. Okay, so on and so forth. Okay, so now I'm asking you to think about what if the power was a fraction? So if you had x to the 1/2. Okay, I want you to think about what that's equivalent to, and then see if you can come up with a way to get rid of that fraction in an exponent. Okay, so I want you to think about that. I want you to try number 1. You can rewrite it if you want to. Yeah, so if you have x to the 1/2, that's the same thing as saying what? Will, how did you rewrite that?
The square root of x.
Yeah, it's the same thing as the square root of x, right? So if you had the square root of x equal to 3, then to undo it, we would know that we have to do what to both sides? Yeah. It's going to take me a little bit to get used to this new guy, this new camera here. Okay, so yeah, you would just square both sides. So then this would be x equals 9. Okay, you can do that when you have the 1/2 as well. Because if you have x to the 1/2, if you just do to the power of 2, I want you to think about what happens. Okay, so when you've simplified exponents with those rules, a power to a power, you multiply. What's 1/2 times 2? 1. So x to the first is the same thing as x. Okay, so it's still going to equal 9. Okay, so based on this, for number 2, we would raise each side to the power of what? 5. Great. So that's what we're going to do. Each side to the 5th power. So it's a power, it's not multiplication. Okay, on this side. So 2 to the 5th, okay, is 32. If you don't know that off the top of your head, you can just multiply it out, right? 2 to the 4th is 16. 16 times 2, 32. Okay, and then on this side, you're left with x to the first or x. Okay, now this one we're gonna raise a power 2 as well. Do you guys have any ideas on how we could do that for the last one? Say it again. Yes, because if you multiply 2/3 by 3/2, what would that do? It would make 1. What's the relationship between these? We call 2/3 and 3/2. They're what? Reciprocals. Great. Okay, so when you have a fraction, you are just going to raise it to that reciprocal. Okay, that's what we're going to write here. To undo a power that is a fraction, we can raise to the reciprocal. Isn't that beautiful alliteration? My lovers of English in here. Raise to the reciprocal. Okay, so then here you have x equals -2 to the 3/2. Well, we know how to simplify that because, did I say negative? We need to change that to a plus. Oh, I guess we don't. Yeah, we do. This one we have to. So we change that for me to a plus. All right, and then this means we have a root and we have a power. Okay, so our power is 3. There's a few different ways that you could do this. You could do 2 to the 3rd inside the square root. Okay, and you do have to simplify. So that would be the square root of 8. Okay, and remember how we're simplifying radicals? If there's a perfect square in that, you take it out. Okay, so 8 is going to be 4 times 2, so 2√2. Okay, and you don't have to do plus or minus here because you aren't doing the solving. Okay, you could still get here if you did, if some of you were thinking this, the way that you would simplify that is √2 times √2 times √2. And what's √2 times √2? 2, so it's 2√2. Okay, so either way you do have to simplify it to that 2√2. Okay, in order to apply this inverse operation, you have to isolate the radical. Okay, or if you have an exponential expression, you have to isolate the base. Okay, so in order to apply the inverse operation, we're going to isolate the radical. Okay, and then we can perform our inverse operations. Okay, so we are going to solve each equation and then check for extraneous solutions. Okay, the reason why we have to check for extraneous solutions is when you have a square root, you can't take the even root of a negative. So anytime there's an even root, we're going to have to check. Okay, the only thing we have to check, though, are the even roots, because for odd roots, that doesn't apply, because your domain would be all row numbers. Okay, so you only have to check the even roots. Okay, that's the only one that has a restriction on it. All right, so then let's go ahead and isolate the radical function. So my first step is to get that radical alone. So I'm going to subtract 5 from both sides. Okay, now the radical is isolated. Once you have the radical isolated, whatever the index is, you're going to raise that to both sides. Okay, so this would be x plus 1. This would be 121 when you square it. Okay, so you get x is 120, and then is it an even root? Yes, if it's an even root, then we check. Okay, so when you're doing your checks, you're just going to plug it into the original. Remember, you can't move things to either side because you don't know if it's equal. So it's 5 plus the square root of 120 plus 1, and we don't know if it equals 16. Okay, so we aren't going to do anything with this side. We just have to see if those sides are going to be equal. Okay, so this would be 5 plus the square root of 121. We know the square root of 121 is 11. So 5 plus 11, 16 equals 16. Yep. So your solution is x equals 120. Okay, if it didn't check, then you would just write no solution as your final answer. All right, so for B, I want you to isolate the radical. So think about what your first step is going to be. So you want to get the radical by itself. What do you have to move over? How are you going to move it over? Okay, so Hudson, what did you move over first here?
I divided by 7.
Great. Okay, so the 7 is multiplied on the outside, so we're going to divide both sides by 7. So then we get the cube root of 5x minus 7 is equal to 12. Okay, now this time it's a cube root. Okay, so if it's a cube root, we are going to raise each side to the power of 3. Yeah, I'm sorry, that one's a little large to do without our calculator, but I did it without mine. Because what's 12 times 12? Yeah, so I did 144 times 12. Oh, or I did, yeah. So when I did 144 times 12, what I did is I split it up and did 144 times 10 and 144 times 2. We got that. Right? We split 12 up into 10 and 2. That's easy. Okay, so if you multiply by 10, all you have to do is add the 0 on there. Okay, and then 144 times 2 would be, you just double it. Okay, that's not as bad as I thought. What about you guys? Is that not as bad as you thought? Oops, 17. Sorry, I started multiplying again. That's a common thing. Hey, and I know we've been off for a little bit, but just to remind you guys, remember, devices need to be in your bag. Okay, earbuds are out. I want you guys to follow along with me. Okay, and then from there, you're just going to solve. So add 7, divide by 5. So 28 plus 7 is just 35, right? Okay, so we just have to divide this by 5. We can do that. Okay, so 5 goes into 17 how many times? 3. 5 goes into 23 how many times? 4. And 5 goes into 35. Yep, so your x is going to be 347. Now, with part B, it's a cube root. So anytime there's an odd root, okay, you do not need to check. What's the domain for any odd root. All real numbers. That's why you don't have to check it. Okay, there's no restrictions. So no check because it's an odd root. Odd roots, the domain is all real numbers. All right, so now we're moving on to part C. And in part C, okay, we don't have to worry about isolating the radical because both sides have a radical. So instead, your first step is going to be to square both sides. Okay, and on this side, if you square, it undoes the root. So you have 8x plus 6. On this side, you can think of this multiple ways. You can think of it as 3 root x times 3 root x. Okay, that might be helpful. Or you can square the 3. 3 squared is 9. What's root x squared? X. So it's just 9x. Okay, so you have to square both of them. Okay, then we can get all the x's on one side. You end up with x equals 6. Okay, and then we do have to check it because it's an even root. Okay, so when you set up your check, all of our first steps should be the same. You have 8 times 6 plus 6 equals 3 root 6. And we're going to put a question mark in the middle because we do not know if those are equal. Okay, so basically what you want to do is you want to see if we can get this side to equal 3 root 6. Okay, so underneath we have 48 plus 6, which is going to be the square root of 54. Okay, that is the square root of 9 times the square root of 6, which is 3 root 6. Okay, so that means this is your solution. Okay, and then D is an odd root, so no check. Based on what we did for part C, I want you to do part D. Well, I want you to at least do the first step. It might need help with the second one. That's okay. Give it a go. All right, so hopefully we started by doing the cube of both sides. And on this side, we get x plus 6. Okay, you don't have to divide by 2 first. You could. You'll end up getting something equivalent. Okay, and then when you cube this side, you have to do 2 to the third, which is 8. And then here you have x minus 1. All right, so when you do the cube root, it undoes the radical. Okay, and then you do have to distribute. So this is the stuff I thought you might need some assistance on. So 8x minus 8 is going to equal x plus 6. Okay, now for these I said you didn't need to do a check, but you can check to make sure that you solve correctly. It's just there's never going to be an extraneous solution if it's an odd root because there's no restrictions on the domain. Okay, but if you plugged in 2 minus 1 is 1. Okay, the cube root of 1 is 1. 1 times 2 is 2. You plugged in 2 here, you get the cube root of 8, which is also 2. Okay, so you can plug it back in and check. It's just when you have an odd root, it will never be extraneous. Okay, which is why you don't have to. All right, did some of you start part E? Okay, so Garrett, will you start this one with me? What do you think we have to start by doing? Yep, so it's a square root, so we're going to raise both sides to the power of 2. Now on this side, you're just left with what's on the inside, negative 3x plus 33. On the other side, I just want you to be careful because often people will just distribute the 2, and that's not what you have with a binomial. With a binomial, we are going to have to FOIL. All right, so if we FOIL, 5 times 5, 25. We have negative 5x minus 5x, negative 10x. And then a negative times a negative is a positive. Now this one's a little different. This is the first one where we've had x squared. Okay, so I'm going to remind you that when you have x squared, what you want to do is move everything to one side, and you want to have this equal to 0. So we're going to add 3x, we're going to subtract 33. Okay, I'm lining up my like terms. Is it okay if I just go to putting them in standard form here?
Yes.
Okay, so the x squared I'm going to put first. Then I have negative 7x. Then I have negative 8. Okay, so the reason we want to put them all to one side is so that we can do what? Factor, that's right. Good job. Okay, so I'm going to start with x and x. This one's pretty simple to factor, right? It multiplies to negative 8, adds to negative 7, so negative 8, positive 1. Okay, so we're going to use the zero product property. It's either x minus 8 equals 0 or x plus 1 equals 0. So x equals 8 or negative 1. Okay, so this is where we need to make sure that we check both of our solutions. So first we can check the 8. And this doesn't have to be a long process. We're just plugging in our 8. Okay, so we get negative 24 plus 33. So we have positive 9. The square root of that is 3. And then 5 minus 8 is negative 3. Okay, so those are not equal. That means this is an extraneous solution. That's why we're checking. So that's not, 8 is not going to be part of our final solution. Okay, if 1 works, that's our only solution. If 1 doesn't work, sorry, negative 1. If negative 1 doesn't work, then there's no solution. So again, we're just going to plug that in. So this is 5 minus -1. Okay, so think about what happens if you have minus a negative. It turns into plus. So 5 plus 1 is going to be 6. So we have to see if that turns out to be 6. A negative times a negative is a positive. So you get root 36. Okay, this is your only solution. X equals -1. Okay, any questions? All right, then I want you to do F. Okay, you can use part E to help you get started. All right, Cal, how'd you start this one? Yep, square both sides. And then whenever you square the square root, you're just left with what's underneath. Okay, and then we have to FOIL here. So if you want to write this out, if that helps, you can do that. Okay, so a negative x times a negative x is going to be positive x squared. Please double check that you did that right. And then -4 and -4 is -8. 4 and 4 is 16. Okay, and then Elijah, once we get here, what do we do now? Before that.
No, I mean, put the terms on it.
Yes, yep. So get all the terms on one side, and you can choose which side you want to move them to. I always like to choose the side that's going to leave that x squared positive because I just think that's a little bit easier. And then, yep, we're going to factor. Okay, so I'm looking for two numbers that multiply to -12. Add to 1. Okay, Haley, let me know when you get that factored. Yep, +4, -3, great. Okay, so then we can use this zero product property that says if these two multiplied equals 0, one of these factors has to be 0. So x is either -4 or 3. So then we just need to check those. Okay, we have to check it because it's a even root. And you cannot take the negative, you can't take the square root of a negative. And so that's why we're going to check that. Let's do, we'll do -4 first. So it can get tricky when you have all these negatives. This is a negative -4 or minus -4 plus 4. Okay, which is going to be 4 plus 4. So you get a +8 here. Okay, this is going to be 36 plus 28, which is square root of 64, so then 8 equals 8. Yes, that is part of our solution. Okay, now we're going to check 3. So again, we're just plugging that in. Negative 9 times 3 plus 28 equals negative 3 plus 4. Okay, so negative 3 plus 4 is just going to be 1. Okay, this is negative 27 plus 28, which is the square root of 1. The square root of 1 is 1, so that checks as well. If both of them check, this is your solution. It's x equals negative 4 or x equals 3. Okay, now when you have an exponent, the same rule with checking applies. So we have to the 1/3 power. Okay, 1/3 is the same thing as the cube root. So this is an odd root. Okay, no check needed here. Just gonna block that off. Okay, and then just like we did on the front page, if you have this power, you are going to raise it to the reciprocal. So the first step is raising each side to the reciprocal of that fraction. So the reciprocal of 1/3 is 3. The reason why this works is 1/3 times 3 is 1. Anything to the first power is itself. Okay, so why don't you finish that one and then see if you can do the first couple steps of the next one. We'll check in. Make sure you're on the right path. All right, and then just double check your answer for G. Okay, and then I asked you to do the first couple of steps of H. So because you have 1/2, we're going to square each side. That's the reciprocal. When you do 2x squared, it's 2x times 2x, so make sure you get 4x squared. Okay, that makes 1, so you're left with 4x plus 8. Going to move everything to one side. And remember, when you are factoring, if you have an equation, you can divide by the GCF if you have an equation. What's the GCF here? What number goes into all of them? 4. Yep, 4 is the largest one. So if you divide everything by 4, you see how much simpler this is going to be to factor? Right? You can factor with 4, -4, and -8. you will get the same solutions, okay? But this is going to be a lot easier on you, right? Because the only thing that multiplies to negative 2 is 2 and 1. So negative 2 and positive 1. So x is equal to 2 or negative 1. Okay, and then this one we do have to check because it's even. Okay, it's all about your root. Okay, so when you check x equals 2, 2 times 2 equals 4 times 2 plus 8 to the 1/2. Okay, so I'm going to help you with this check. Okay, so 4 times 2 is 8. 8 plus 8 is 16. So this is 16 to the 1/2. The 1/2 is the same thing as what? Square root. So what's 16 to the 1/2? 4. 2 times 2, 4. Okay, so remember that that is the square root. So you can just go from here to here. That's fine. Okay, so 2 is one of our solutions. Let's see if negative 1 works. Okay, if they both don't work, your answer would be no solution. Okay, and I put that line down to remind you that you can't add things to both sides. Okay, so you're not sure if they're equal. So negative 4 plus 8 is going to be 4 to the 1/2. That's going to be 2. On this side, you have negative 2. Okay, so this is extraneous. Okay, so your solution is x equals 2. Okay, now on this one, you have the parentheses and you have this 3 on the outside. So I would recommend dividing both sides by 3 first. You can't distribute it. Okay, and then once you square both sides, you get x equals 3. And you have to check because it's an even root. So 3 plus 6 to the 1/2 equals 9. 9 to the 1/2 is 3. 3 times 3 is 9. They are equal. All right, so a few things. I'm going to show you your 6.6 homework.